I would like to welcome you all to the Standard Library tour, but first let me tell you just a bit about myself. So I'm a software engineer working at Atacama. Atacama is a Canadian Czech company that specializes in creating data products. We are focused mostly on data quality, and I'm working on a product that visualizes data. Apart from that, I have over 5 years of experience in IT industry. I've worked for multiple companies, and I tried different roles. I'm based in Prague, Czech Republic. I'm also very involved in community work. So I'm the main organizer of Prague Python meetups, PIVO. I'm co-organizer of Czech PyCon, which was also this year. I'm co-organizer of EuroPython. I got involved in 2023 when EuroPython was in Prague. And I'm also the main organizer of Prague Python Pizza, which will happen in 2024. So what does it mean is that if you're in Prague, drop me a line. I would love to meet. You can visit some of our meetups. You can visit some of our conferences or even EuroPython. And we are always happy to see more people. And also if you would like to give a talk, for example, or just to meet some people, just drop me a line. All right, so probably most of you are familiar with this, but just to ensure that we are all on the same page, let me just quickly mention what is the standard library, because I'll be talking about it today. So it's a collection of modules and functions which are included with Python, so it's built in. It offers numerous functionalities without installing third-party libraries, and these functionalities include things like interacting with operating system, running servers, scientific computing, debugging, data manipulation, and many more. So now let's talk about why. So you might be wondering, but why is it important? Like, why should you know anything about the library? Why just not implement the features yourself, for example? So if you're using the library, you're not reinventing the wheel, because these solutions have already been developed. Also, not only that they have been developed, but also they have been optimized, and also it can help you to avoid many bugs that have already been fixed, comparing to when you're, for example, implementing something from scratch from your own. So just to manage the expectations, let me just quickly mention what is this talk about. So it's a brief overview of the lesser-known features of the standard library, and the aim is to discover the unknown unknowns. So the unknown unknowns are the features which you probably didn't know that exist in the library. So the library is huge, right? So I was thinking about what to talk about, because I could be talking about it here the whole day. So I started thinking about 2 dimensions. One is, which are modules well known, meaning that you probably have worked with them, comparing to which are less known, meaning that you have probably not used them. And also I started thinking about what are the things we as developers do in our daily life. Things like, the idea is basically to discover some features which could help us with our everyday, daily developer lives. So that said, we will not focus on less-known modules which do less-known things, because that's something which we probably don't do very often. It's something for a small niche audience. And also, I don't want to talk about top 5 modules from the library, because if you Google it out, you will probably find it there. But instead, I would like to focus on the other 2 quadrants. So let's start with well-known modules which do less-known things. So let's see what's hidden in the modules which all of you have probably used. Just a small disclaimer, all the code examples that will be there, they're just illustrative. Whether to use the standard library or something else, of course, always depends on your specific use case. I chose very easy examples for you to be able just to follow it. So Functools, how many of you have ever used it? Raise your hands. All right, so I would say half of the audience. So Functools, it's one of the most frequently used modules inside the library, and it includes a variety of tools for working with functions. That's why Functools. So these tools include things like modifying function behavior or creating some function-like objects. So let's see some example. Let's say we have a function which adds 2 integers together. And the function should handle both integers and strings and input. And when given integers, the function should add them together. And when given strings, it should concatenate them with an empty space in between. So here you can see an example of how you could do it. So you basically use isInstance. And if we try to run it with different values, we can see that it behaves as expected. So this is functional. However, there might be another approach how to solve this problem. So you can use the single dispatch decorator. So here we can see that we have on the line 4, we have single dispatch decorator. And it's above the function add. Then we specify the behavior for each type in a separate function. So if user enters integers, the function defined on the line 10 is run, and that one adds the integers together. But if user enters strings, then the function on the line 15 is run. And for all other cases, the value error on the line 6 is returned. So single dispatch, it's used for function overloading. Just a small reminder, function overloading is creating several methods with the same name, which differ from each other in the type of input parameters or the number of input parameters. And it's commonly used for cases when you work with different data types as inputs to your functions. So for example, I've seen this at work, that we use it in an example where we were parsing input data from some files, and we did not always know which kind of data type is our input, so we use single dispatch, so just to have all of these cases covered. So you might be wondering, but why this approach using single dispatch might be better than the first one when both of them are functional? So the advantage is it's easier to modify because you have multiple functions, and each function handles one type. They're independent, so they can be modified independently. The code is cleaner and more readable. And however, the downside is it dispatches only for the first argument. So that means that if you have multiple arguments, then you would have to use some third-party libraries. So let's check some more examples in the Functools module. So let's say we have a function that adds two numbers together, but very often we add by 2. So you might write something like this, where you define the default parameter. And now you have to add by 3 as well. And you say, let's say you only add by 2 and by 3, so you don't want to have like a common add function, but only by 2 and 3. So you would maybe write something like this. But you're duplicating the code, right? So what you could do instead in these cases, so you could use partial. In this case, we've defined a function called add, which acts as some sort of a template for other two functions, add to 2 and add to 3. And then we use partial to pass add into these functions, defining an argument in each case. So in this case, the core logic is kept in one place, and multiple partial functions are able to reuse that code. So when we run it, we can see that it returns the correct result. So partial, it's used to create a new function with some of the arguments of the original function, and it can be used with any kind of callable, like built-in functions, methods from other libraries, args, and quarks. So now you might be wondering, but what is the advantage, or why just to use it instead of just using the default parameters when it also works? So the main advantage is code reusability, so you're adhering to the dry principle, dry meaning don't repeat yourself. And common case is when you need to call a function with the same argument multiple times. So for example, the example I've seen at work is that we had a function where we called various API endpoints, and there was an authentication header that we must pass each time when we make a call. And if you set its value and you refer at it at each place where you call the API, then the authentication method suddenly changes, then you have to update all of these references. So you would have lots of places where you call it. But if you use partial, you can centralize this logic, and this way you would have one function which defines the header, and then you could reuse it at multiple places. And in that case, if the header changes, then you would just change it at one place, and all other places could reuse it. It has also its downsides, same as everything. So it's not very intuitive for new Python developers. So for example, if your team is very junior, or you have programmers coming from a different programming language that doesn't have partial functions, maybe in that case you would rather want to sacrifice reusability for better readability. So let's see some more examples from partials. So we have this Fibonacci function. This function is recursive, and it does some sort of, let's say, expensive operation. Is there any way how we can improve it and make it faster and maybe more efficient by using the library? So we can use the LRU cache decorator. What does this decorator do is that it essentially caches the result returned by the function. So the function doesn't need to execute the code every time. It can return the cache results instead when they are available. And also from the version 3.9, we can also use the cache decorator. So least recently used decorator, it stores the results of function calls. It checks for the key in cache dictionary. When the key is present, the wrapper results the value and updates the cache hit info. And in case that the key is missing, then the wrapper calls the user function with the arguments, updates the cache miss info, and returns the result. And if the cache is full, then LRU cache evicts the old items and adds new ones. So you might be wondering, but what is the difference between LRU cache and cache? Is there any difference? So as said, cache, it's available only from version 3.9, and basically is the same as LRU cache max size none. And it doesn't evict the old item, so it's faster. So I made a small experiment. I benchmarked average execution speed with and without caching, just to mention that this is not a precise method. So if you use it across different runs and machines, it will give you different results, but the ratios are typically consistent, so we can just check the rough comparison. So we have three functions: Fibonacci without caching, with LRU cache, and with cache only. And you can notice that the cache versions are noticeably faster. So the caching does speed up our code. And we can also see that the performance of the LRU cache and cache-only versions is approximately the same. So let's explore some more well-known modules. How many of you have ever used Itertools? OK, so it's around half of people. So Itertools, they're used for iterations, basically. They provide various functions to create iterators and for efficient looping. And they're useful when you're handling large data streams. So let's start with an example again. So let's say I need to calculate the Cartesian product of two lists. So here we see that we have two lists and two nested for loops, and we can iterate over both lists, and we can see that it works. However, instead of calculating it by ourselves, we can use instead Itertools.product. And you can see it returns the same results, but it's way more clean and it's more short. So product, it returns the Cartesian product of two iterables. Let's see some more examples. Let's say I have a list, and I want to filter elements that are in another list. So we can use the built-in function filter, which does exactly that. Now you might be wondering, but why do we want to do the opposite? So we want to filter the elements which are not in the list. So something like not filter. So we can call Itertools to the rescue. So we can use filterfalse, which is exactly the opposite of built-in filter. So filterfalse, it filters elements from an iterable, returning only those for which the predicate is false. And it is the opposite of built-in filter. So let's see some more examples with Python built-in functions. We have two lists, which we would like to combine together. And notice that the first list contains 3 elements, while the second one contains 6 of them. So what does it happen when we run this code? When we run this code, we can see that only the first 3 elements are merged together, which might be surprising for someone who, for example, doesn't work for a long time with Python. I was also very surprised when I saw it the first time. Why? Because it doesn't take the elements for which there is no value in the first list, so basically just discards them. But what if we want to have all the elements zipped and we just want to fill in none, for example, in case there are no elements in the first list? So in that case, we can also use Itertools. We can use the zip longest function, which fills the value for the missing elements. And we can also set up our own value, which we want to be there. So here, in this case, we have none, but it doesn't have to be none. It can be any arbitrary value. All right, so far we've talked about Functools and Itertools, and I would like to mention one more well-known module which is also very commonly used and has some interesting hidden features. Collections. How many of you have ever used it? Raise your hand. Okay, also around half of people. So let's say I have multiple dictionaries. Here we have two dictionaries, and I need to find some key. So you could do something like this. However, what happens if there's 10 dictionaries and not only 2, like in our example? So in that case, our if, elif, else statement would grow, right? And this approach is functional, but it might not be the best approach. So let's see if we can somehow improve it with a standard library. So what we could do is we could use ChainMap. So here we add all dictionaries to the ChainMap class, and ChainMap groups all dictionaries together. So when you're searching for a key in the ChainMap, it will search for it in all group dictionaries, and it will return you the first result it finds. So now you might be wondering, but how about creating a new dictionary and using the update method to add all the data, like we see here? So in this way, we also group all dictionaries into one, and then we iterate over it, and this is a functional approach. So the difference is that ChainMap references already existing dictionaries and doesn't copy any data, while the update method in the previous example does. So that's why ChainMap is more efficient. So how does it work is that it groups multiple dictionaries into one. It provides a single dynamic view. And when one of the dictionaries gets updated, the update is visible in ChainMap as well. So speaking of dictionaries, what happens when we attempt to search for a key that doesn't exist, like in this example? So the key error happens, right? And is there anything we could use from the collection model to prevent the key error? Because sometimes you're searching for something and you don't want to have the key error. You want to have something else, for example, because what you're searching for is not in your dictionary yet. So it happens that collections, they have a subclass of the dictionary class that returns a dictionary-like object, which is defaultdict. So the difference is that we can use it with non-existing keys, and it doesn't return the key error. Instead, it supplies the missing values with the value that was passed. So in this case, we instructed to supply the missing values with a none value, and when we run it and try to access value for a key that doesn't exist yet in the dictionary, we can see that it returns us none, and it doesn't return us the key error. So defaultdict, it's a container-like dictionary. It returns a default value for a non-existing key. It is commonly used for grouping or counting elements in a collection, and it can make code simpler. It can make it more readable by eliminating the check if a key is already present in the dictionary before doing operations on it. And now you might be wondering, but what if my structure is nested dictionaries, because that's something that we use very often? Can I still use it? Yes, you can. You can have multiple nested dicts with the default dict as well. So now I would like to move to the second part, less known modules which do well-known things. So these are things which we do on a daily basis, for which there are some tools in the library that it might be useful to know them. So testing. I will not ask you how many of you write tests, because I hope that all of you do. There are certain frameworks for testing APIs or web applications, and you can find lots of materials on the internet about testing. However, today I would like to focus on one less explored topic, and that's quick and dirty kind of testing without using any framework. So, for example, when you have some small scripts. Let's say you have a small script like this. It calculates something. it's not inside some big code base where you have proper tests and framework and everything, but just some small script which you run on your PC every day. And it's important for you, and let's say you want to have some kind of assurance that it still works. And ideally, you would maybe want to have some documentation as well, so you don't have to write it as well. So I discovered the Doctest module. So it works in a way that you add some examples in the doc string, which are both tests and documentation for your string. So if we run it, we can see that nothing happens, which is normal because there are no errors in our example. But let's say here that we change our test. So notice the line 10 where we change it from -15 to 15. So if we run it again, we can see that our test failed. Expected 15 got -15. So testmod module, it's used for very simple scenarios. It's used for quick and dirty kind of testing and also documenting simple scenarios. And these test cases are readable for humans in a way that it allows you to test and to document your code in the same time. Comparing things. So it's something also that we often do. And it happens that in the standard library, there's lots of different tools which can be used for comparing things as well. And these tools are not very often well known. So let's see some examples. Here we have two strings. And let's say we want to compare if they're the same, or if not, we want to determine how different they are. So what we can do is that we can use the Difflib. Here we create an instance of the differ class, and we compare two strings. And if we print the result, we can see that all the characters are the same, except the one on the line 8, which is missing in the second sequence, and the one on the line 9, which appears to be in the second sequence. We can also calculate the ratio of the comparison between two sequences. So that means basically, in other words, how similar or how different these sequences are. And here we can see the result, 91%, which means that they're very similar. So Difflib, it's used for comparing pairs of sequences of any type, like strings, tuples, lists, etc., as long as the sequence elements are hashable. It uses Radcliffe-Obergefell algorithm. If you're interested in that, you can read more about it. And we can also measure the similarity of the sequences, where there are values between 0 and 1. 0 means no match, 1 means identical match. And a rule of thumb is that the ratio of value over 0.6 means that sequences are close matches. So those were sequences. And how about other things? For example, files. Can we compare the contents of two files as well? So we can. It happens that there is a module for that in the standard library as well. So here we have two files. And what we can do is that we can call the CMP function from the file CMP module. And when we print the result, we see that it returns true. That means that the file's type, size, modification time, and content are identical. So that means that our files are basically equal. And that was files. And now you might be wondering, and how about directories? So for directories, there's another method. It's dir.cmp, which compares to directories. And when we call the report method, we can see the difference. In this case, we can see that the file1.py is only in the directory 1, while the file2.py is in the directory 2. So for comparing files and directories, you can use the file CMP module, which defines functions to compare files. And dir.cmp class constructs a new directory comparison object to compare two directories. And it provides also multiple functions to define what to compare and how to show the results of the comparison. And it can be useful for cases, for example, we have different versions of the same project. And the last great feature from the standard library I would like to talk about, it's a context manager, and this is a feature which we use very often. So let's see an example. Let's say we have a file which we need to open, we want to do something with it, and then at the end we need to close it. And for this, we could use the context manager decorator. So how it works is that we write a function where we define our operation that is supposed to happen at the beginning before we use it. and at the end, after we have finished our work, and then we use the with statement to use it. So if we run this example, we can see that first we open the file, then we wrote to that file, which was an operation inside the with statement, and at the end we close the file. So Context Manager, it defines a factory function for with statement contexts. It provides a clean, easy-to-read way to manage resources that need setup and teardown phases. And also, you can nest multiple context managers with blocks to use them at once or in a single with statement by separating them with commas. For the example, when you're opening and closing files, you can use the built-in function open, which does basically the same. But other common use cases, which I've seen at work, is, for example, when you're acquiring and releasing a lock, when you're working with network connections, working with temporary files, changing and restoring global settings. And now you might be wondering, OK, but these functions were sync, and what if my function is async? Does it work in the async context as well? So the answer is the one I showed you doesn't, but there's another decorator for it in library as well, and if it's the async context manager. So here is the same example, but only async. So basically, it works exactly the same, and here we can see when it runs it, it behaves exactly the same. The only difference is sync versus async context. All right, so we have covered the second part where we talked about less-known modules which can help us with everyday things we do. And there were lots of examples and a lot of code. And if you don't remember all of this, it's perfectly fine. I know it was a lot of it. But at the end, I have two key takeaways which I would like you to remember. So the first one is the standard library. It is packed with very powerful tools, so don't be afraid, deep dive into it and check out all the tools that are there. And the second one is always verify if there's an existing tool for your task and if it suits your needs before attempting to create something from scratch. Thank you very much for your attention, and now it's time for your questions.
Thank you, Mia. Thank you for the wonderful talk. I hope we all learned something. So if you guys have some questions, I can bring the mic to you.
Hi, a question specifically about the single dispatch decorator. I noticed there were type annotations in the slide. How does that play with the type checkers?
Sorry, can you repeat it one more time?
Sorry, in the single dispatch decorator, there were type annotations in the slide.
Yes.
How does that play with things like MyPy or the type checkers? Does it understand the kind of polymorphic aspects of that, or is it? I imagine that might produce some strange MyPy results.
Yes. So let me find it. I haven't seen any issues with MyPy in general, because here you can see that all of these functions are. Oh, you mean like the return type of the function, right?
Yeah, or just generally that. I mean, it understands that the first example is 2 integers and the second example is 2 strings. But if you start calling those with types, or if you call add with floats or something elsewhere, how does the type checker recognize that?
Yes. So in general, I haven't seen any issues with MyPy, and that's because these functions are separated. So for example, if you would add here floats, it would go to line 6 and it would raise value error because floats are not defined here. Here you can see only ints that are defined and strings that are defined, and these ints return ints and string return string. In case you would add more types, there would be no issues because you would define it in the function. So you would define that your x is now float or your x is tuple or list or something else. And if it's not, then it just raises value errors. So basically, because all of these functions are separated, right? Because the return on the line 11 is very different from the return in line 16 when we talk about data types. In that case, like there is no guessing; these data types are separated. So MyPy would have no issues with this one.
Okay, cool. Thank you.
You're welcome. Thank you.
Yeah, maybe we can take one more question. I saw someone raising their hand there. No? Oh, you're there?
There's To that last question, that I think is override. There's a decorator called override that lets you define multiple definitions. So methods that, for example, the behavior changes depending on whether you get an integer or not. I don't know how it ties into that, though, and if the two of them are compatible. But it does exist.
All right, so it's 4:15 here, so we will be calling up the next person. Anyways, thank you, Mia. Thank you for your talk.